So today we are going to see one interesting problem, sliding window median. Hope my screen is visible. So in the sliding window median problem, the problem is they have provided a list of nums array and they have provided k. We need to split the subarray into k length, 1, 3, for example, 0, 2, 0, 1, 2, that is 3 length, then 1, 2, 3, then 2, 3, 4, 4, 5, 6, 6, 7, 8, 9, 10, 11. Okay. Uh, sorry, 6, 6, 7, 8. Okay. In the 6, 7, 8, we need to uh, give the middle of the number. Okay. For example, in the 0, 1, 2, the middle number is 3. If the k is 4, then consider 0, 1, 3 minus 1, 3. So these are the subarray. Okay. So the middle number is the median is 3 minus 1. So that is 2. Okay, so the answer would be in the doubles 2.00 something. Okay, so uh, from reading this problem, I thought to use of the slide segment tree. So in the segment tree, there is one pattern, kth problem pattern. Using that, we can solve many problems. So there is no lot of videos about that sliding segmentary kth pattern. So let's look at this pattern in this video. Actually, it is a very simple pattern, but it's very powerful. And the time complexity of the building segmentary is O of n, and updating the index would be O of n. Querying would be O of log n. So actually, we can use lazy propagation to reduce that update into of login, but I'm not covering in this video. So let's look at the segment tree. Hope my screen is visible. So now this is the array 1, comma 3, comma minus 1. And first, what we need to do, we need to sort this array. Okay, this is the actual array. This is the sorted array, and this is the map. Okay, map or list. In the list, we are adding minus 3 in the index. In the map, we are reading minus 3 would be the key and index would be the value. Okay, in the map. And k equal to 3. First, we need to build the tree. So, what we can do, these minus 3, minus 1, these are leaves. Okay, so what we can do, these would be here. Minus 3, minus 1, 1, 3, 5, 6, 7. These are all leaves. So, what we need to do, we need to split this array. Okay, and then we need to pair. Okay, uh, minus 3 minus 1 would be 0 comma 1 comma 1 would be 0 1, 2 comma 2 2 comma actually the position is 0 comma 0, 1 comma 1, 2 comma 2, 3 comma 3, 4 comma 4, 5 comma 5, 6 comma 6. And we need to these are as this binary, we need to take left and right. Okay, the if we take left and right, 0 uh, 0 0 1 1 will be 0 1, 2 2 2 3 3 will be 3 3. Uh, and 4 comma 4, if we mal 4 and 5 would be 4 comma 5, and if we take this this is left and this is right, so 4 comma 6, similarly 0 1 2 3. This is how the trees are built. The index of the tree will be Okay, highlight in different color. This is 0, zeroth index, then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so the number of array is 0, 1, 2, 3, 4, 5, 6. So total 7. So we need to build maximum in the worst case 4 star 7. That is 28 in we require a 28 index in the segment tree. Okay, so let's see how we can solve this problem. For example, in the first we need we'll take the first three digits. Okay, 1 comma 3 comma minus 1, and this is the index of that sorted nums. Okay, 0 1 to minus 3 minus 1 1. First we need to update these first three index with value 1. So if you do that, 0 comma 0 will be 1, and minus 3 we are updated, minus 1 1. First three sorry, not this one, not the index position. We need to update the 1 comma 3 comma minus 1. Okay, so first value would be 1. What is the first value of index of that minus 1? So that is 1. Sorry, 1. That is index 2, right? So we'll go to the index 2 and we'll update with value 1. And what is the index of the 3? 3 would be 3. So we'll go and update this value with 1. Okay. And what is the next digit? Minus 1. What is the index of that minus 1 in our map? That is 1. Okay. So this is the 1, right? 0, comma 1, comma 1. So this we have updated. We need to update now we have updated the leaves, right? So we need to update the uh, index trees. How we can update it? So 2 comma 3 comma 3 would be updated as 2, and remaining values are considered 0. Okay, and now 0 comma 1 would be 1, and the total of 1 comma 2 would be 3, and this side will be 3, and this side all 0. Okay, uh, consider these are all 0. Now now we have updated the tree. Now we need to get query which number is the uh, kth element, right? For that, there are k equal to 3. We require this is odd number. If this is odd number, then the kth number would be k plus 1 by 2. This is our middle number, right? So 0, consider we have a 0, 1, 2, and what would the index of that middle number? So that would be 4 by 2. So if k is odd number, then we need to take actually it's not 0 index, it is 1 comma 2 comma 1 1 based. Why? Because we are updating the 1. Okay, for example, these are 1 2 3. Okay, 1 2 3, and we need the middle number 2th position, correct? These are all 0th based. We are taking whatever the index updated with 1, and from that we need to take the second element, correct? So 1 2 3 we need to take, because all these are updated with 1 2 3. Okay, not 0. Okay, so we need to if k is 3, we need to get the second element, right? So for that, k plus 1 by 2. If in case if the k is 4, then we need to take 1 comma 2. Sorry, k plus 1 by 2. If k is 4, 4 by 2, then 2 comma 3. This will value we need to take in case k is 4. Okay, hope this is clear. So now k equal to 3, we need to find the middle number, right? So we need the index of 2. k equal to 2. Second element we have needed. Okay, so how we can find? From the zeroth index, uh, the query would be the low index 0, comma. First, we'll start from the root. Okay, 0, comma 6. Low equal to 0, high equal to 6, and uh, left would be what is the left value, and mid. These four we required. Okay, first low equal to 0, comma 6, and high equal to 6, and now root equal to 3. Okay, and what is the value? K equal to 2. Okay, if k is 2, the what is the left value? Value also 3. Okay, so this 3 is came from the left tree. Okay, so left equal to 3. If k is less than or equal to 3, 2 less than or equal to 3, right? So in that case, the second element would be reside on the left side tree. Okay, so we need to go left. So to go that, we need to calculate the mid. Okay, what is that? 6, 0 plus 6 minus 0 by 2 equal to 3. So mid equal to 3. We need to traverse to 0, comma third tree. Okay, so this tree 0, comma 3. And now we high would be 3. What is the left value? Left value is 1. Okay, now 1 less than or equal to 3. False, right? So the second element reside on the right side. So we need to go to go the left side. The formula is 2 star position plus 1, right? If the position is equal to 0, how to go the left side tree? 2 star position plus 1. How to go the right side? 2 star position plus 2. Actually, these are all basic left-hand tree structure, but I should have covered in the middle. Apologies. So now, if we go, if 1 less than or equal to 3, right? It's false. So our second element is on the right side. So what is the mid of that uh, tree? What is the index? What is the range we need to look? For that, 3 by 2 equal to 1, right? So we need to look 1, comma 3, correct? We need to look on the 1, comma 3. So if our position is 1, then 2 star 1 plus 1, that is 3. So we need to look on mid, comma right. The right value is 2 star position plus 1, position plus 2. Actually, our sorry, we need to look. We need to go into the uh, we need to go into the high, not here. We don't need to look that left and right, 2 star position plus 1, and left, right, right. We not search. We need to look for the low, comma high, because we are only care about this low, comma high. So, what is that high value? We need to look for the 1, comma 3. Correct. Actually, 3 by 2 equal to 1. So we need to look for the 1, comma 3, right? Second. My mic is getting turned off. So, sorry. Our starting position is 0, comma 3, and 0, comma 3 we need to traverse it to 2, comma 3. So the left side would be 0, comma 1, and the right side would be 2, comma 3. Correct. 0, comma 1, 2, comma 3. We need to traverse into 2, comma 3. Okay. So in the 2, comma 3, when you go to the 2, comma 3, we need to minus that left value. For example, the kth value, k is 3, left equal to 1, right? So we need to look for the second elements. The k will be reduced. So k now becomes 2. Okay. Now We are in the 2 comma 3, and we need to look for the uh, left element. Correct. So now we are in at 2 comma 3, and what is the left value? That is 1. Correct. And what is the mid value? That is 2 comma 3 would be 1. 2 plus minus 3 equal to 2. 3 minus 2, 1 by 2 equal to 0. So this is low plus high minus low by 2. So that is the formula to calculate the mid. So that would be 2. Okay. So now we need to check 1 less than or equal to k. Sorry, k less than or equal to 2. That is true, right? Left value. Actually, our k is actually sorry, our k is 2, right? So we need to look for k minus 2 would k would become 1. So now 1 less than or equal to 1. Left side would be true, right? So uh, we need to take the 2 comma 2. What is our, we need to go on the left side. Now our low would be 2 and our mid would be 2. So that is 2 comma 2. So we reached low double equal to high. So when we reach low double equal to high, return the low. So that is 2. So this is how we need to traverse. So once again I repeat. So first the k equal to 2. We need to get the second element of that k, right? So we need to start from the 0 comma 6. So from that 0 comma 6, 2 less than or we'll calculate the left side. 2 less than or equal to 3. So that is true. So k less than or equal to left. Then we'll go to the left side. If not, then we'll go to the right side. If we go to the left side, left comma mid. If you go to the right, if you want to go to the right side, then mid plus 1 comma right. Okay, or high. Okay. So from 0 comma 6, we need to go to the mid of 0 comma 6 is 3. So we go to the 0 comma 3. So now we'll calculate the left. Okay. The left will be 1 comma 1. If 2 less than or equal to 1, false, right? So our second element is not there. So we need to move to the right. So now k would be reduced to 1 because we already found the left side element. Now we need to traverse it to the right side element. So our k would be k. We are k. We need to check k minus left elements because we looked left elements. Okay. Now we need to check for the leftover element. So k minus left, that would be 1. So if we check, so now, then we are going to 2 comma 3. Okay, mid plus 1 comma right. So that is 2 comma 3. In the 2 comma right, 3 we are checking left element. Left would be 1. Okay, left would be 1. So now left would be 1. Now if we uh, check for the left, 1 comma 1 less than or equal to 1. True. So we are going to left. So now the range would become 2 comma 2. So if we 2 comma 2 double equal to 2, then we need to return the 1. So this is how we need to code. Now we'll look at the code for a better understanding. One second, let me open that code. Oh, my screen is visible. So now let's look at the problem. First, we need to build the segment tree. Okay, so that is tree. What is the size of that tree? That is 4 star n. If we have 7 elements, then that would become 28. Now, this is the update logic and this is the kth finding logic. Okay, so here we'll pass the index that from the map we get the index and we need to update the value with 1 and the position initially would be 0, our root would be 0, then low would be 0 and high would be the length of that n minus 1. So that is 6, okay, 0 to 6. And mid equal we are calculating mid. If index less than or equal to mid, then we need to look for the left side. So that is the position would be 2 star position plus 1. We are updating the left trees, that is 2 star position plus 1 and 2 star position plus 2. And once we update that left and right, we need to update the root. Okay, so if you look at the uh, our building trees, every time first we are updating the left and right subtrees, and finally 1 2 here 2, and finally we are updating with root, right? So that is what this logic is doing. We are start from the leaf and we are traversing and updating the roots. Okay, so this is the tree of position, this is left and right trees. To find the kth, if low double equal to high, we need to return that low. Once we find 2 equal double equal to 2, then we need to return. And we need to check the left, whether actually from the left only, we can take anything left or right, okay. But uh, only we need to check whether our k element is present in the left or right trees. That's why we are taking that left, okay. Left side will be tree 2 star position plus 1 and mid equal to low plus high minus low by 2. Okay. Once if k present in the left tree, then k 2 star position plus 1 and low comma bid. We are traversing to low comma bid position. Okay. If in case not, then we k minus left and 2 star position plus 2 and mid plus 1 comma high. So this is how we are calculating the we are returning finding the kth element. So and here we have created a map and list, and we have created a copy and we are sorting that copy and we are updating the map, creating a map with unique elements and its index. And here first we have updated k elements, and this is normal sliding window pattern, sliding with fixed constraint pattern. And if k is odd, then k plus 1 by 2. If k is even, then k by 2 and k by 2 plus 1. 1 if k is odd, 0, 1, 2, 3. We need a 1 and 2 position, right? So this is what we are doing here. Hope this logic is clear. Thank you.